So now we are going to understand electric dipole. Electric dipole moment is a system consists of two charges of equal magnitude but opposite in nature and separated by some distance. And here you can see this is the system that represents electric dipole. And here the charge are q and minus q having same magnitude, but it is positive and this is negative and separated by distance 2a. And here O is the center of the dipole, and this length a plus a 2a is known as dipole length. Electric dipole moment is a physical quantity which is equal to the product of either charge of electric dipole and the dipole length. Okay, so the formula will be P is equal to Q into 2a. Electric dipole moment is a vector quantity whose direction is from minus charge to plus charge, and its SI unit is coulomb meter, or it can be written as C dot m. The electrical dipole moment have a very important physical significance in chemistry. If a molecule have electrical dipole moment not equal to 0, then such molecules is known as polar molecules, and if the molecules has electric dipole moment equal to 0, then it is called non-polar molecules. So now we are going to understand electric field at axial position due to electric dipole, and here you can see that the electric dipole consists of a minus q charge and plus q charge, and here the dipole length is 2a and O is the center of dipole, and P is the point on the axial position of this electric dipole, which is situated r distance from the center of the dipole. And here you can see that the distance between plus q and p is r minus a, and distance between minus q and p is r plus a. And simply we have to find out the electric field at this point p due to plus q charge and due to minus q charge, and after that we will add according to the superposition principle of vector addition. Okay, so first we have to find out the electric field due to plus q charge, that will be equal to 1 by 4 pi epsilon naught q by r minus a square p cap. P cap represent the direction of electric field due to plus q charge. As we know that the direction of electric dipole is minus from minus q to plus q, and also the direction of electric field due to plus q charge is in the same direction of p. So we can write the electric field due to plus q charge as this form. Okay, and due to minus q charge, the electric field direction will be opposite to the direction of electric dipole. So we use minus sign that tells the direction of minus electric field due to minus q charge. Okay, so the net electric field will be vector sum of these two electric field, and here we can see that the electric field due to plus q charge and minus q charge are opposite to each other. So the resultant will be electric field due to plus q charge minus electric field due to minus q charge. And after the putting the value of E plus q and E minus q from this two equation, we will solve it, and after that we will get net electric field will be 1 by 4 pi epsilon naught to p by r cube along the p cap. Okay, so the direction of resultant electric field will be along the direction of electric dipole, that is from minus q to plus q charge. Okay, and here you can see that the electric field due to dipole is inversely proportional to r cube. So now we are going to understand electric field at a point on the equatorial plane, and here it is the here p is the point situated on the equatorial plane, which is r distance from the center of the dipole, and the distance between plus q charge and p is root under r square plus a square, and the distance between minus q charge and p is root under r square plus a square, same value. So this is the isosceles triangle, and so the if the this angle is theta, so this angle will be also theta, and here the electric field at point p due to plus q charge will be this value, and its direction is from b to p along bp, and the electric field at point p due to minus q charge will be this value, and its direction is along p to a. So here we see that there are two electric field acting on this point p, and but the angle between E plus q and E minus q is 2 theta. So the resultant of E plus q and E minus q can be calculated by using this formula. Okay, since here the magnitude of E plus q and E minus q is same, and if we replace E minus q magnitude as E plus q magnitudes, so the formula will be 2E plus q cos theta, and if we finally put the value of E plus q in this place, and cos theta is equal to a by root under r square plus a square. So the final result will be this value in the vector form, and here we see that the direction of resultant electric field and the direction of electric dipole is opposite to each other. So that's why we use a minus sign here, and this is the p vector that represent the direction of electric dipole moment. Okay, so here we also see that the electric field at equatorial position is inversely proportional to r cube, and also we can say that the magnitude of electric field at axial position is 2 times the magnitude of electric field at equatorial position if the distance r is same in both conditions.